je voudrais tout d'abord remercier les organisatrices. C'est un grand plaisir d'avoir écouté tous les collègues. Je suis désolée, je vais continuer en anglais parce qu'il me fait un peu de pratique en français. My research in Malia considers the residential area of P and the material which derived from the later excavations conducted in the area, as described from the colleagues earlier in the presentation. The material under study considers 150 vessels for spaces and rooms in P, as they mentioning in the table, that covering from MM3A to LM1A phases. This study is part of my ongoing PhD project, which focuses on the study of function and use of cooking vessels in Minoan Crete through an interdisciplinary study on the ceramic assemblages from Malia P and from the neighbor settlement of Sisi from context recently excavated under the auspices of Belgian School of Athens. Past studies applied in cooking wares provided interesting results through their role in cooking processes and through preparation practices and their participation in various social practices. The reconstruction of such processes, the understanding of their continuity, variability, or transformation could provide useful insights on the socioeconomic developments and cultural identities of the society. Adopting a functional approach on the study of cooking vessels, the aim is to enhance our understanding of cooking practices and culinary traditions of Minoan communities, and eventually to provide new insights into the related sociocultural aspects. The holistic approach to this study has a diachronic perspective and the interdisciplinary methodology, which combines different techniques of analysis, examining both the intended function and the actual use of the vessels. These different techniques of analysis are macroscopical analysis of morphotechnological characteristics of the vessels, the systematic use wear analysis, the application of organic residue analysis on the content of the vessels, and contextual analysis. Morphological analysis focuses on the examination of the functional properties of the shape and the form of the vessels, including the size, aiming to approach the functional meaning on the different forms of the vessels, their functionality and utility during the cooking procedure. For example, cooking jars with ovoid or globular body and deep forms are appropriate for boiling or simmering the food, while more open and shallow forms in small sized vessels support the faster evaporation of liquids and enable easy access to the pots during the cooking. The 3 feet attached on broad or narrow bases of cooking pots help on the better stability of the vessel and provide better control of the heat at the lower part of the vessel. Open and shallow vessels like cooking dishes and trays are more appropriate for roasting, frying, and baking food, while the round bottom of the first and the flat of the second indicate different use and cooking method. Based on studies on pottery technology, cooking vessels have to follow specific technological requirements and mechanical properties due to their demanding function. They are fired in lower firing temperatures and have high temper concentrations. Those properties provide high thermal shock resistance to the cooking vessels and assess their overall suitability to the cooking function. Thermal conductivity and heat transfer could influence the technological choices of firing methods as well and could be correlated to different cooking techniques. As a recent technological study from Akrotiri and the cooking vessels has presented. In Minoan cooking vessels are indeed low-fired, coarse with non-plastic inclusions of phyllite and quartz and some calcareous inclusions as well, which gives them high resistance to repeated thermal shock. However, they share common technological features with other functional categories of vessels, like the medium-sized storage jars, which makes the distinction of the cooking function of a vessel difficult without taking into account the use marks of the vessel too. Moreover, in tripod cooking pots and cooking jars, we have a variation in the wall thickness which could affect the cooking technique. Thin walls in tripod cooking pots are even trimmed in some cases to have a thinner possible result, a choice which provides better heat effectiveness but decreases the strength of the vessel. To better understand the different technological choices and their relation to the function and use of cooking vessels, different technological variables are registered systematically in this ongoing study. To overcome the direct correlation of form or mechanical suitability to the function and to approach aspects of the actual use of the vessel, the use-wear analysis follows. Repeated uses and practices create characteristic patterns of abrasion or wear with regular association, which help to the recognition of cooking pots and the modes of use of the vessels. The systematic recording of macroscopically observed surface alterations include the registration of different variables of the use marks such as type, location, shape, orientation, texture, coverage, etc. Examples of these use marks identified in P material are carbonization, which is located on the exterior surface in soot patches which are formed during the exposure of the ceramic to the fire and appear with discoloration of brown, gray, or black color in different patterns or shapes, location, coverage, and section, and with charred patches as well, which are deep in section, affecting the color of the clay and the core of the clay. On the interior surface, they are deep black charred marks connected with a residual deposition. Second category of use marks are the antrusions, which are connected with non-abrasive uses, such as the connection with a heat source. Some surface alterations which are not connected to the original use of the vessel are important to be distinguished, such as the firing clouds that originate from the firing process of the vessel and have a purple-gray color with no specific pattern, and the complete burning of the vessel, which gives the uniform gray color to the surface and the clay matrix and originates from a fire, destruction, or post-deposition events. With a systematic study of use marks, the recognition of jars used in cooking procedure was possible. Those jars, as I mentioned before, share common typological and technological characteristics with medium-sized storage jars. Moreover, the potential use of some calathos vessels as lids in cooking jars could be proposed, as they present the use marks connected to cooking practices. In order to approach furthermore the actual use of the vessels, content analysis applied by integrating two techniques of organic residue analysis, Starch analysis and Lipid analysis, which are relative to the questions of this study. The combination of two analytical methods give the potential to identify a large range of possible cooking practices, as both together provide a large range of different commodities potentially used and processed in the ceramic vessels, such as cereals, pulses, vegetables, animal fat, beeswax, etc. The organic residue analysis applied required a well-defined sampling strategy on ceramic vessels and the systematic application of good practices on both the collection and the preservation of the vessels, following specific protocols to avoid contemporary contamination of the samples. The final selection of the pottery samples considers representative amount of vessels and took into account vessels erosion, contamination parameters, as well as typological variation and contextual information. The final interpretation of the obtained results will be correlated to the available environmental and contextual data. Firstly, lipid analysis, which is a method relevant to the identification of food substances rich in fats, such as vegetable oils, animal fats, etc. The identification of biomolecular components in the Aegean archaeological environments concern mainly lipids, which are better preserved in the archaeological record and artifacts than other compounds. The results obtained from the various studies in ceramic containers from the prehistoric Aegean and Minoan context provide valuable information for the foodstuffs and natural products used or consumed within the ceramic containers. This analysis requires a combination of two analytical techniques, gas chromatography and mass spectrometry. The lipid analysis in P is an ongoing project conducting in collaboration with Dr. Maria at Harokopio University. The recovery of the samples obtained just last summer were 2 grams of ceramic material sampled from the interior surface of 10 vessels for analysis. The analysis of the microbotanical remains considers the detection of starch grains and phytoliths that derive from food products used on the artifacts. In particular, starch grains analysis gives the opportunity to detect basic starchy ingredients of ancient diets such as cereals, pulses, root vegetables, and fruits, which were used, consumed, or cooked in ceramic vessels. Most microbotanical studies from archaeological pottery focus exclusively on the analysis of cooking vessels due to the good preservation environment provided by charred food remains. Moreover, methodological studies applied on the alteration of the starch morphologies during cooking or food processing enlighten more the aspects of food cooking. In my non-archaeology, microbotanical analysis applied on grading stones in Malia by Harabakupiu, and recently in ceramic vessels in Knossos Ipsades in LM1A deposit, showing that microbotanical remains are well preserved on my non-artifacts and could provide valuable information for different archaeological issues regarding ancient plant use, food preparation, and consumption practices. From P, 15 samples from cooking vessels selected and analyzed for starch and 4 sediment control samples too. Residue recovery consists of two-step process where a dry sample and a wet sample collected. The sampling, processing, and analysis of microbotanical remains followed very specific protocols described thoroughly in the publication mentioned in the slide. The starch extraction, processing, and microscopic analysis of the samples conducted on the School of Archaeology in the University of Oxford. The first step of the analysis was the detection and the preparation of modern comparative samples and the formation of a reference collection. Multiple data sets were taken into account to form a list of modern comparative plant species for this study, including archaeobotanical evidence from my known context in Crete, textual information from linear B tablets, ethnographic data regarding the consumption of edible wild plant species in Crete, particularly in relation to root vegetables, and historical sources. A total of 41 plant species were included in the modern comparative collection for this study, representing different plant food categories such as cereals, pulses, nuts, vegetables, and condiments. All the preparation of the reference correction and the study of the plant took place in Oxford and in the Wiener laboratory in Athens. A total of 14 morphotypes were identified which were diagnostic at different taxonomic levels of plant species, such as Triticea, Fagoidea, Pancoidea, Cyperus, etc. I will present briefly the results occurred from the analysis, which you could find in detail and discussed in the forthcoming paper that we submitted with my collaborator Garcia Granero. The preservation of the starch grain in both case studies is very good and comparable to previous starch studies in ceramic vessels from my known context. Starch grains recognized in comparison with a reference collection and were arranged in 8 taxonomic categories that you could see on the table and which regard different types of plant foodstuff, including cereals, underground storage organs, commonly root vegetables, potentially spices, and some unidentified plant species. Those results already expand the information we have about my known diet and enrich aspects of food preparation and consumption in Bronze Age Crete. They will be further correlated to the use and function of each type of cooking vessel. For now, I will highlight some aspects of each category of the foodstuff. The presence of domestic cereals in the starch assemblages is not surprising, as the microbotanical evidence supports this data too. Cereals were identified in different types of cooking vessels, suggesting that a variety of cooking techniques, boiling, stewing, roasting, were used to prepare cereal-based meals, which will be further analyzed. The absence of pulses in the starch samples from both sides analyzed clearly diverges from the microbotanical evidence. This absence, it could be related to the low preservation of pulse starch grains in my known vessels due to taphonomical processes, which doesn't seem to be the most possible hypothesis since we have good preservation of starch from other plants. Alternatively, this absence of pulses may be reflecting aspects of the social context of pulse consumption in minor urban centers and peripheral settlements. This working hypothesis needs further examination. However, it's worth to mention too that pulses are not referred in administrative minor palatial records, contrary to other stable crops such as wheat and barley. The presence of cumin type starch grains, it constitutes different direct evidence of the use of condiments in Minoan cuisine, which are lacking from the microbotanical evidence. According to the administrative text Culinary tablets, cumin is among others exotic commodity. Further pottery and contextual analysis currently ongoing could enlighten the context of consumption of this exotic commodity. Moreover, based on the comparative collection created for this study, we're able to identify starch grains from Cyperus esculentus tubers, tiger nuts commonly, in correlation in particular with cooking dishes. Sorry. According to ethnobotanical evidence around the world, this plant species has multiple uses, including fodder, medicine, perfume, and food. The tubers, the tiger nuts, are the edible parts of the plant, which contain more oil and starch. They could be eaten raw as a vegetable, tasting sweet, or boiled, roasted, or as a flour or edible oil. In modern Greece, it is known as ground almond, amygdalo edafous, or manna of heaven, manna turanu, but is not currently cultivated or consumed. Archaeobotanical remains of Cyperus species have not yet been reported in the prehistoric Aegean, but the presence of this taxon among charred remains it is not excluded. Its cultivation has been suggested in Akrotiri Thera by Anaia Sarbaki. Moreover, Cyperus esculentus is mentioned in linear B tablets called Kuparo, where its Cypriot and East origin is referred. Furthermore, Sedis depicted in two Minoan wall paintings in the Bronze Age Aegean, one in Akrotiri Thera and one in Knossos unexplored mansion, could be identified as potentially Cyperus esculentus. A long history of cultivation and consumption of this plant species is documented in archaeobotanical data in Egypt since 3rd millennium. The cooking and consumption of tiger nuts in prehistory is depicted in a wall painting in Vizar Rekmael tomb in Egypt from 15th century. This example is very valuable not only because scenes of cooking are rare in wall paintings in general, but also because it has an inscribed recipe which describes the preparation of a sweet pastry, a biscuit or a cake made with tiger nut flour and honey, and is cooked and fried with some kind of a fat within a pan. The starches of Cyperus esculentus tiger nuts observed in our case studies from Minoan context, mostly from cooking dishes, which look surprisingly very similar in morphology and function to the pans depicted in the Egyptian tomb. This evidence, thus, could suggest that Minoan cooking dishes could have been used to process tiger nuts, which is a so far unknown culinary practice in Minoan cuisine. This hypothesis, of course, needs further examination. The very sporadic presence of Cyperus esculentus starch grains in other vessel types, such as tripod cooking pots and the jar, attest to the use of this plant species in the Minoan diet in general. Lastly, I will conclude by mentioning the last step of the methodology of this study, which is the interpretation of the different outcomes through the contextual analysis. This study is still ongoing. All the outcomes of the different techniques of analysis that I mentioned, the related traditions and novelties recognized in the culinary scene operatura will be approached firstly at the micro-regional level and secondly at the inter-regional level. Thank you very much for your attention.